Hello and welcome to the last of the Bio43 pre-lab videos for week 1. In this video, we're going to talk about hypothesis testing, how we evaluate our hypothesis based on the data we collect in our experiment. Clearly, this is a part of using quantitative reasoning to analyze experimental results, but it's also a key part of thoughtfully designing experiments. By the time you perform an experiment, you should already know how you plan to analyze the results. Let's continue with the experiment we designed in the last video. We hypothesized that trees lose leaves in winter due to decreased daylight. Our experiment involved a control group that consistently received 12 hours of light each day, and an experimental group where the amount of daylight gradually decreased over time. And we predicted that a greater number of leaves would fall from trees in the experimental group than the control group. The first step in hypothesis testing is identifying the null hypothesis and alternative hypothesis. The hypothesis I just mentioned is actually our alternative hypothesis. It's an alternative to the null hypothesis that leaf loss is not affected by the amount of daylight. The null hypothesis, the independent variable not affecting the dependent variable, is our default assumption. Through our analysis, we will either reject our null hypothesis, which supports our alternative hypothesis, or fail to reject the null hypothesis, in which case the alternative hypothesis is not supported. We never absolutely prove anything in science, and certainly not from a single experiment. Now we take the data we collected in our experiment and check it for structure and quality. The best way to organize your data will vary based on your experiment. You just want to make sure it's in a form that's easy to interpret and work with. Double check there aren't any missing values or mistakes made copying data from your notebook to a computer. Next, we calculate summary statistics. The summary statistics we use depend on the variables we're dealing with. We established that our independent variable is categorical and the dependent variable is continuous, at least from a practical standpoint. For that scenario, the summary statistics we want will be the mean and 95% confidence interval, which you can see how to calculate in your statistics guide as well as future videos. These are the most common summary statistics we'll use, but we'll show you other scenarios as they arise. Then it's time to plot the data. Again, the type of plot depends on the type of variables. Our situation calls for a bar graph, where the bar heights are the means and the 95% confidence intervals are the errors. That will give us a plot like the one shown here. The plot helps us visualize the difference between the treatments, but it doesn't tell us if the difference is statistically meaningful. For that, we need to perform a statistical test. And once again, which test we use depends on our variables. When dealing with a categorical independent variable, it can also depend on the number of treatment groups. Since we have 2 treatment groups, we'll use a t-test. Further videos will go into more depth on statistics, but the important thing for now is that each of those tests will provide a p-value. A p-value is the probability of getting data like we've collected if the null hypothesis is true. So let's say the p-value for the data displayed in this graph is 0.003. This tells us that if the amount of daylight did not affect leaves falling, there's only a 0.3% chance that random variation will cause a difference in means this extreme. Because that's so improbable, we reject the null hypothesis, which in turn supports our alternative hypothesis that trees lose leaves in winter due to decreased daylight. Our typical threshold is 5% or 0.05. With a p-value less than 0.05, we reject the null hypothesis. Greater than that, and we fail to reject the null hypothesis. So the alternative hypothesis is not supported. Again, that's just support or not support. Nothing has been proven or disproven. So that's that. Only thing left to do now is write up the report. I hope this video series has provided you with a good overview of what it's going to be like as a principal investigator in this lab. Don't worry if not everything is clear yet. We'll go through these processes with more concrete examples over the coming weeks before you have to do it yourself. Be sure to come back to these videos as well as your experimental design and statistics guides as needed. See you next time.